For a function y is equal to fx, the y prime of the first derivative of the function gives the gradient at any point x, and second derivative gives the curvature at any point x. Now let's say we have a function y is equal to x square. It's a parabola of the form x squared is equal to 4ay. So I'm assuming y 4a to be 1. So let's say it's like this, and y prime is 2x. So we can see the gradient is a straight line, the gradient profile, and it is like this. So this point is where the minima is. This will be the minima. So this is where the minima lies, and if we go to the left, we can see here the gradient is negative, very negative, and the negativity slowly decreases. It becomes 0 here, and then the gradient becomes positive. So this point gradient is negative, the negativity decreases. Here the negativity is 0, the gradient is 0 basically, and then gradient becomes positive, more positive, keeps going on positive. So that's how it is. And if we see the second derivative, it's 2, which is a constant, and if we forget the number, the sign is a positive. That means the curvature is like this, and this is called concave up. This is how it's called, it's concave up. That's the curvature of a parabola. And now if we have a function like this, y is equal to, just y is equal to minus 2x square, 2 minus x square. So y prime will be minus 2x, and here again the gradient will be this. Now this is a straight line with a negative slope. So the change of gradient, the rate of change of gradient is a constant, is a straight line, and the gradient of this straight line is fixed. This one was 2 for that particular one. Here this is minus 2, and the gradient, if we draw the curve, it will be like this, and this point is where the maxima lies, which is this point. Here the gradient is positive, maximum positive, the positivity slowly decreases. At this point the gradient is 0, then it becomes negative, and negativity keeps increasing. Here is maximum. So this is where this point is this point, and then maybe this point is something like this, and then this point is probably this one, this point, this one, so on. So this one is called, this kind of curvature, y double prime is negative 2, and the sign negative, that means this is like this, which means concave down. And this part up to maxima, this curvature is called concave down but increasing. The gradient is concave down decreasing, and here it's concave down increasing. The gradient is slowly increasing like that. So if there is a point when if we have second derivative to be 0 or y double prime to be 0, that point can be a point of inflection. Now the point of inflection is where the curvature changes. That means that to the left it has one type of curvature, so the second derivative is probably positive or negative, and the other on the right hand side it will be different type of curvature. And if that happens, this point is called point of inflection. So for a function like this, so maybe like this, it's not a very perfect drawing though, but maybe like this, something like that. So this point can be a point of inflection if the second derivative is 0, and whether it's a point of inflection or not, in order to check, we go to the left and see what's the sign of the second derivative, or what's the curvature. If the second derivative here is negative, and if the second derivative here is positive, if the signs are different, then we know that this is a point of inflection. So this is the first criteria, is this point has to be, the gradient, the second derivative has to be 0, and to the left it's negative, to the right, on the right it's positive, or here it's positive and on the right it's negative. If that happens, that means the curvature is changing from left to right. So this is a point of inflection. Now if this is negative, this is a concave down and this is a concave up, so this is more likely to be like this kind of situation. And we can have something like this. If we have something like this, maybe, so basically this point can be a point of inflection as well. So here second derivative is probably 0, let's say the second derivative of, so basically second derivative is 0, this point, and we go to the left and see what's the second derivative, and we can see that this one is concave down, so this one is second derivative is negative, and here the second derivative is positive. Basically the previous situation. The other situation can be like this, and then maybe I will draw here, so maybe like this and then maybe like that. So here maybe there is a point of inflection. Here the second derivative can be positive, and here the second derivative can be negative. So this point, when the second derivative is 0, first we check whether this second derivative is 0, then we go to the left and see if the second derivative is a positive, that means this is a concave up, and on the right, if the second derivative is negative, we know this is concave down. So this is how we know that this is a point of inflection, and we can actually, from an analytical function, we can sort of draw the curve with all this information.